Hi, welcome back to the channel. Thanks for tuning in again today. As you can see, 582, I've already inspected in the exhaust ports. It doesn't look pretty in there. You might want to refer back to a video I did several years ago on inspecting the piston rings, and then you get an idea of what it should look like when you inspect through the exhaust ports. So anytime the engine lays down really bad, before you fly it again, I suggest that you take the exhaust manifold off, look in both the exhaust ports carefully, and make sure that it doesn't have a piston cylinder problem. Because of course there's no point in fiddling around with spark plugs and gas filters if the engine's already burned up. So anyway, enough said on that. As you can see, I got the head bolts all loosened off, and let's find out what we see when we lift the cylinder head off. Oh yes, and apparently this had some aftermarket pistons put in it recently. To say the least, the owner of the engine was not very satisfied with that repair. So now it's my turn. Now I have to figure out what happened to it. Was it these aftermarket pistons? Was it something else? So this is the part that gets difficult. It's easy to change the parts back and forth, but when you have to find out what actually burned it up, that's where the tough part comes in the diagnosis. Okay, let's lift off the cylinder head. Oh, right away, I see a big issue here. Well, the O-ring came, stuck onto the cylinder head. The colors on the combustion chambers indicates to me this engine's been pretty hot. But the real giveaway is check out these, get that out of the way, these outer seals. They're just shredded, kind of like, if you took a pencil eraser and rubbed it on a piece of paper, then look at all the streamers on here. So these are either super low quality or this engine has been run exceptionally hot, because it's basically melted these guys that go around the outside of the cylinders. So you can see everything that's, it's like the head and everything has just been constantly moving from temperature, either getting too hot, getting too cold, which is why we get this here. Let's see if I can pick one out of here. There we go. So this nice edge on it here, this is what we should more be seeing on the top, rather than this where it's all melted and been rubbed and abraded. So let's have a look in the PTO cylinder and see what we can see. Let me get a little bit of light in here, see what works the best. Maybe like that. So I can see some crosshatch here. I can see crosshatch over a lot of it, but over top of the crosshatch or through the crosshatch, we can see these shiny areas here. There's another one here. There's one over here. Now, why is it like that? And then if you do notice, there is a line that goes right down here, which is the where the ring gap is in the top piston ring. So that's a normal little mark down there. It's because and I already know, of course, when I see this rubber ring in this condition, the engine has been heat cycled, super hot, cooled, whatever. When I see this, to me that means that the piston expanded so much and much faster than the cylinder expanded that it lost its clearance and was right next to transferring aluminum like it did in the other cylinder, like right there. So why would it do that? It could have had insufficient clearance to begin with. I don't know what size these pistons are, who made them. It could be just run the temperatures are so extreme, or maybe, you know, this is, you can get this from an overshoot as well, when the engine is, you know, has cooled a little bit, and then you know, if you're one of those guys that just hammers the throttle wide open on overshoot, then the piston is going to get much bigger in diameter much faster than the cylinder is going to match that increase in diameter, and you can lose the clearance. And that's what this did. This is from pretty much zero clearance in between the piston and the cylinder wall at a particular temperature. So that's what you would call, you know, your cold seizure. Far from being cold, because it's when it's hot, but the cold seizure thing, this piston here, I'm sure will have a 4-corner seizure on it. Let me look at the other side and see what we got here. And yes, we have some over here as well. So it was next to seizing for sure. And this side here, oh yes, look at the transfer there. So this is our mag side again. So we've got lots of transfer here on the exhaust side. Right where we saw it before was on this side, which was not the exhaust side. So here's the exhaust side, and I can feel that with my pointer. It's gouged out pretty good. Now that could be aluminum deposited on the surface of the sleeve, or it might be just chewed into the sleeve, and it'll need to be rebored. So now we can say, well, this one almost seized, this one did. Just for the theory of it, if both of these pistons were the exact same diameter and both the cylinders were the exact same diameter, why would this cylinder, the mag cylinder, be the one that would, you know, stick that bad, to actually rub metal on metal, aluminum on steel, and transfer the aluminum onto the cylinder wall? Well, what we have at this end of the engine, we have the magneto. This makes a fantastic amount of heat, and it's all mounted inside of this protrusion here that's like a little oven, and it just gets hotter and hotter. So this end of the engine runs at a much higher temperature than the PTO engine does, as far as I'm concerned. So let's, anyway, let's get the cylinders off. Now I've got the engine standing on the mag end, because if there's any dirt that's around or particulate in between here, between the cylinders, I don't want it to go and fall inside the engine. So let's give it a little tappy here. Tighter than normal. Okay, we'll put that aside. We'll dump out the bolts. All right. So yeah, they're definitely aftermarket pistons, that's for sure. There we've got our circlip removed. And we'll go in with our piston pin puller and get the piston off. We should be almost out now, or out soon. Yes, we are. And then what I always do is I just push all the loose rollers through, so they're all captured in the piston. I don't have to chase them all over the bench. We'll move the engine aside from our removal tool. Interestingly, maybe you can see it in the light there. This pin is all blue on the end. You see the ends? It's all blue. This has been pretty hot. which goes hand in hand with what we saw so far. Let me clean up this antifreeze that fell down here. We'll put a piece of towel here. All right. So more than just counting them, we need to see what they actually look like. So I'll get my magnifier down here and have a look at a few just random ones for right now. Oh, they're not exceptionally blue. They don't show any signs of extreme heat. But the ends of the pin being hot, absolutely. So the oil they use in this engine must be pretty good. If they were using any what I call boat oil, then these roller bearings are just blue as could be, because of course the boat oil that won't withstand the kind of heat that these engines generate, so they don't lubricate properly. All right, so when I was talking about heat on the top and how it's, I kind of look at it like you burn something in a cast iron frying pan, and this is the carbon that's left over because it was burned, like some butter or grease or something. So what really tells a big tale is when we look in the bottom side. Again, where's my flashlight? Going. Normally we see in here a little bit of black, which down at the very bottom there you can see a little teeny bit. But this is just completely evaporated anything that was there. That's amazing. So what kind of a piston is this? No, okay, I can see some numbers on the top. I'm gonna wait to get the other one out because I think I can see the numbers better on the other piston. Get our bag here for the mag, right? A little bag with an M on it. And let's get this pin out and find out what we got on this one. Because of course this was the way worse. This was the much worse piston as far as melted went. When I quickly looked at the other piston that we've already taken off, the PTO piston, I think I really see the problem already anyway. You can't never just jump to conclusions and go, oh yeah, I know, I see that. That must be what it is. You really need to look at a lot of different things and go, okay, well, it's not that. It's not that. It's not that. And a lot of times you find a lot of not that before you find out what the only and real reason is. Because there's generally not many reasons. It's usually one reason. There'll be a lot of things damaged maybe, but there's always one base cause of the problem. So that came out reasonably well. And of course, I'm just going to push all of the needles into the piston, and one tried to escape, but that's okay. We'll just push this back out of the way now. Definitely is blue on the end. So that, shut that off. That was a machine like a steel color, not a blue color. Whoops. So it should be like a nice shiny steel, polished steel color, and it's not. Okay, now in the bottom of this piston, flashlight, we see the same thing again. It's the strangest looking coking I have. Usually it's coked up really thick. So this is a little unusual color under there. And of course we can see, let me give this a bit of a wipe. So these pistons have that black coating on them. where are we here? The black coating on it that's supposed to be, you know, super thin and really slippery so that it wears in better. And it was covered the whole side here. Of course, it's gone in the center. The ring's, of course, trapped in here because it's pinched. Oh, where are we here? Get the light better. It's pinched right there from where it melted the piston, so it's just melted into the groove. So here's the numbers that I came up with when I measured the pistons on the skirts and the cylinders, averaged it out, and this is my piston size is 2/998 thousandths, and the mag cylinder is 3 inches and 5 thousandths, with a clearance in between the piston and the cylinder of 7 thousandths of an inch. That's a lot. PTO piston, 2 inches 998 thou. PTO cylinder 3 inches and 6 thou, with a clearance of 8 thousandths of an inch. That is huge clearance. It fit too tight. In other words, they bored this 10 thou over, or a 1/4 of a millimeter oversize. Did they not give it enough clearance? Oh, there's lots and lots of clearance. Go and measure the pistons. This is there's I marked it right here. That's the dimension to measure the piston at for diameter, and I'm pretty accurate there. So it's not like there's a whole bunch wore off of these, making the piston way too small. So the piston size way too small. But so I'm getting down to the point now where I think I know what actually happened to this engine. And these are the things that I have to go through to figure this out. So I'm going to eliminate the fact that it had not enough piston to wall clearance. So think about it now, and what else do you think could be the problem? We can see in the crankcase here, we're in the PTO side, the color there, and we can see the difference, the black that's in this mag end here. So, you know, another indication of how hot it was, just burning the oil right on there. You know, as soon as I removed the stator, of course, before I split the case, I looked at the seal and I went, that's not right. This is just some cheap seal. Does it fit? Yeah. Is it correct for this application? Absolutely not. This is for like a Skidoo or a Sea-Doo or something. And this is just an old one. This is what it should look like. And I'm not sure if you can see the color in here. It's brown right here because it has a Teflon lip. Why does it have a Teflon lip, and why is that important? Because when this crankshaft, this piece of metal is spinning inside this seal at cruise RPM, it's doing 57 or 5800 for hours and hours and hours. This is going to slide freely on the steel surface of the crankshaft. This rubber, there's no way this is a Teflon lip seal. It's just a cheap rubber one. It's probably going to want to weld it or melt itself right onto the crankshaft. I mean, why somebody, well, they don't know, obviously. This is not what you want to put in an airplane. I'm sure there's guys out there that use these cheap seals and get away with it. Well, that's fine. I mean, I can't do that. I have to use the proper stuff, the proper material, so that I don't have a problem with it after. Now, silicone, well, just like a lot of times on the internet, you know, I guess they buy a full tube of silicone and they want to use it all in one job. This has got way too much silicone on it. But the worst part is that, so now I've already taken this half of the crankcase over to the cleaning machine. And what do I see? I see all kinds of lines on it. Why has it got lines on it? I had to dig a little bit to find this. Somebody used one of these things to clean it. So all the way across here because they don't know how to clean it properly. What did they do? potentially ruin this whole surface. The only part of this surface that they missed in wrecking or damaging is this little bit right here. This is the factory finish right here. The rest of it has been all sanded, ground, whatever you want to call it, with some type of a power tool, sander, I don't know what they used on it, instead of cleaning it properly. How warpy is this? Can I use it again, or is it ruined? Because if it isn't flat, I mean, these things are almost perfectly flat when they're made. They just need a little taste of silicone here, just in case it's out like a half a thou or something. Well, it's probably out way more than that, because you can imagine with one of these things spinning away, it's going to make one heck of a mess of it. So if you're ever going to clean your own crankcase, don't use power tools. Oh my goodness, look at that. It's just black, cheap, garbage seal. Even has silicone on it, because apparently they had a whole tube. Anyway, this is not the kind of parts that you want to put in your aircraft engine. It's just not worth it. There's a bit of a difference. Now, this is a used one that's, you know, I saved from throwing in the, I actually got it out of the garbage can just to see it on here. So you visually, pretty big difference. But when we look at everything about this, it's just not the same. It's just cheap garbage. Use the good stuff. It is an airplane. So here's the economy rubber versus the real Rotax aircraft seal. There's visually quite a big difference in these. And of course, we don't have any kind of Teflon at all on the lip here. And we definitely have that brown Teflon on the real seal. So this is, to me, is just so much of a risk to use cheap stuff when, yes, the appropriate and correct seal costs more. There's a reason that it costs more, because it's actually better. So let's examine these crankshaft main bearings on the mag end. And you see all these striations coming out from the center here, all this brown, likely rust, corrosion. I see right away it has steel cages in it. Totally wrong for an aircraft engine. It should have the fiberglass reinforced polyamide bearings in it. And so these are, who knows what quality, where they came from, what they're supposed to fit. Don't know. Don't belong in an aircraft engine at all. So let's spin it around and have a look at the PTO end and get this in the right place. So I already rubbed it a little bit here, but we can see there's coating, black coating on it. And we can see, well, compared to the other end, the mag end, I mean, look, it's just black as coal in here. I'm not sure what that's from. The bearing is a little bit stiffer to turn. Now, one of the things that I do notice about this, and I'm not surprised, because whoever worked on this was not in the using any kind of specs like for aircraft or anything. There's a specification for a clearance in between the bearing and the seals, the seal right here, and it's not maintained at all. There's barely any clearance in there, and that lets the oil move through to the rear bearing especially, and it should move back and forth, and it really doesn't. So just another example of somebody put it together, didn't really know what they were doing apparently. Not to, maybe to sled specs, but not to aircraft specs. So 2 bearings for here, proper clearance. But before that's done, then we're going to need to make sure that the connecting rods clearance is salvageable, and we can use this crank again and have a look at some other items on it. So maybe we can save this one with 4 bearings if we put it all together properly. So let's check the concentricity or the straightness of the crank. And the reading on the mag end, I'm just zeroing it here, it looks excessive. And it is, it's like 2.5 thou, which is high. Let's see what we have here. 1/2 thou on this bearing here. 1/2 thou in this position right here. And let's see what we have on the mag end. Sorry, the PTO end. And yeah, it's pretty close to 2 thou on the PTO. So a little over 2 thou here, 2 thou run out here, and the center is acceptable. So at this point, the crankshaft needs to be trued because it's not straight. We need to put 2 mag end bearings on because they're some kind of non-aircraft bearings, and the same here, because remember this was fitted way too tight because apparently they don't have any specs or anything when they do this, they just jam it together. So next thing to do is I want to check the clearance in the big end of the connecting rods, and we'll see if this is a candidate. Should we put bearings on it? Should we true it? Or are the rods wore out? We'll see. So I used my special tool to check the clearance on the big end of the connecting rod. The PTO end has 1/1000ths, and the bearing looks very nice. Every roller through the little window in the rod. This one, because it's had debris going through it, it is at 1 6 to 7/10. So this one here, the mag end rod, which is the one where it had the failure, the scraping failure of the piston with all the associated debris, is at 60% wear. This one down here, the other one, is actually at the high end of new spec. So it's unfortunate because that's probably how this one was when it had those cheapy pistons put in it. So that's the end of this crankshaft. So before I can clean the crankcase off and see how damaged the surfaces are, I have to take out the cross shaft, remove it. I have to take the water pump impeller and remove it, of course. As you can see, I've got the nut off already. And I look and I go, well, I can fit the screwdriver underneath the impeller. So the impeller is, proud of where it should be. It's too far out in this direction towards the water pump housing. So I get the housing and I look, and we can clearly see where the impeller, most of the blades have been rubbing on here. So at this point, with what I see and the way this engine was serviced before, I'm really not that surprised. So I put the crankcase halves back together, as you can see, tightened up all of the bolts, and I'm just going to do this visually to see how poor the joint is across in between the two of them now that the surfaces have been damaged by this poor cleaning job. So I'm just going to use a bright light, which is going to be on my inspection camera. And let me position the camera again, and we'll see what we get. So let's get the bright light and shine it against the backside. Oh, you can see light through there already. So right at the very edge here, no, but a little further in, so we can see the light sparkling, shining through there. Let's go in a little further. And Let's see what we get here. So isn't that something? There's that much material. Whoa, look at that spot right there. So I'm sure we can all see that light shining through there. Hard to hold it steady, but there we go. Now the surface, when they've machined this crankcase 2/2, it's like perfect metal to metal. It really it needs such a small amount of sealer because it really is just a metal to metal joint. With that big of a gap in there, because it was, there's material missing because they cleaned it with power tools. The silicone that you put in there, would it seal it? Yeah, well, maybe for a bit, maybe for a long time. I'm not sure. But one day, because the silicone is just sitting there filling a gap, it's either going to get sucked into the engine or it's going to blow out, and that's going to create an air leak. There's other places, but it failed right here, so I'm not going anywhere else to check it. And the engine, when it blows out that silicone, it's going to run poorly. It potentially seize up, stop. Big air leak in the crankcase. So this crankcase is, there's no way I'm going to use this crankcase again. It's been ruined by whoever cleaned this with power tools. So what did I find here in the end? This all started out with these aftermarket pistons and rings. The wrong ring package for an engine that's going to run at high RPM all the time. It looks like to me it has a chrome top ring and just a plain cast second ring. Should have moly coated piston rings in it. So totally wrong. The heat that generated with all of that friction, I don't know if you can see it in here, but you can see in the where the cooling system part is in here, there's just a line across there. This thing was so hot with so much friction from the ring package. And very not the proper angle on the crosshatch on the cylinder. So then we have the water pump not assembled correctly, the impeller's rubbing on the housing. We have, cheap, not aircraft. This is the seal from the mag end of the crankshaft. And all the debris that this was making from the failure of the piston, all of the debris that went through there ruined what otherwise was a good crankshaft. Yes, it needs 4 bearings because they put the wrong, they put non-aircraft bearings on it. And then, of course, the one connecting rod on the cylinder had the failure. It's 60% wear already. The other cylinder is within new specifications. So it's, these cheap pistons really ended up costing an awful lot of money, unfortunately. And of course, we have the crankcase, as you just saw, that is all the surface on it. The mating surface is ruined from cleaning with some kind of power tool. Who knows? I don't know what they used on it, but it was cleaned improperly and it damaged the surface. We need a crankcase. We need a crankshaft. We need pistons. We need to bore the cylinders. In reality, it's just more economical to just buy a new short block, because this is basically, with the exception of the cylinder head, this is just all junk. So it's very unfortunate, but I have to take these engines apart first to find out what they actually need. And then I can do a full assessment, which I did here, and you've seen exactly what I saw. And as I said, it's unfortunate, but it's just cheaper to buy a brand new short block and move along. We dressed that all up with the ignition system, the other components that were on this engine, and off it will go and fly some more. So anyway, thanks for watching. Hope you enjoyed the video. Like, share, subscribe, all those other things. We'll see you again.